Gude! There are really lots of great free open source TTS or text-to-speech projects and artificial voices available that are hard to differ from actual human voice.
Thank you very much for this compliment.
Oh, sorry, eSpeak voice. I really do not want to hurt your feelings.
He is talking about me, buddy.
True. In a LinkedIn post by WeBe or he pointed out some really cool open source text-to-speech projects like ChatTTS, Mars 5, MetaVoice, Parler and Toucan, just to call them in alphabetical order. And in this overview comparison video, you will hear how each of these free TTS voices is sounding. And I'll take a first look on aspects like homepage, license, programming language, performance, voice cloning support, supported languages, and what's special for each of these projects. Did I miss anything?
Please subscribe to this channel as your host is amazing.
Oh, thank you. And do not forget to hit the notification bell, because I will give all of these TTS projects a closer, more in-detail look in the upcoming videos. And to kick this off, let's start with...
Hello, ChatTTS is here. Please pick me.
Okay, so let's start with ChatTTS. Let's start by listening to an audio sample how ChatTTS is sounding. And there are multiple ways you can use ChatTTS without any local installation. So there is this ChatTTS website, as I've shown you here right now, and there is an embedded, I guess it's an embedded frame from a Hugging Face space. We'll take a look to that in a moment. So let's just take an input text and just put any English or Chinese text here. I'll leave the default values and hit generate. So now we have this output text, which is a little bit modified, as you can see. So this is good morning. This phrase is the reference to compare several available with a break and free TTS models, break again, and finally a last break. So this is being added automatically by this website or Hugging Face space. So let's listen how this sample is sounding.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am just curious on the results.
Okay, so it's a little bit struggling with that phrase here. So let's make it with that phrase. But please let me know in the comments on what you think on the quality of ChatTTS out of the box with the default values. Next, let's take a look to the homepage of ChatTTS, or in that case, the multiple home pages of ChatTTS. So let's start with the website 2noise.com, which is pretty simple and clean. We have just this one page here and two links to GitHub repository. The code is open source of ChatTTS, so this will bring you to the GitHub repository, and to Hugging Face, where you can see more information on the model, the usage, and you will find any spaces on Hugging Face where you can play around and test ChatTTS without any local installation. So let's first of all go to the GitHub repository, and you can see this code repository. We'll take a closer look to the repository in a second. Next, let's take a look to the Hugging Face page, showing you some model card information here. So the model card and how you can use the model. This might have similarities to the GitHub repository README. And on the right side of this page, you can see spaces that are using this ChatTTS model, such as this, for example. And if you click that, this will bring you to the Hugging Face space using ChatTTS model, where you can just insert your text and play with ChatTTS model without any installation. And as you might see by the design, so keep this design here in mind, if we hop on to the next page, we can see ChatTTS.com website. So here this ChatTTS.com, and if you scroll a little bit down on this page, you can see this embedded frame, which in my case seems to be a frame taken from the Hugging Face space. So should be no difference to use this ChatTTS.com website for testing or the Hugging Face space provided by the project. And last but not least, you can install it, but we'll take a look to that in another in-detail video on ChatTTS. You can install it by code or using a pre-built ChatTTS Python package under pypackageIndex.org and search for ChatTTS, and there we'll find the pre-built package of ChatTTS. By now it is in version 0.1.1. Next, let's take a look to the license of ChatTTS, and for that we'll hop back to the GitHub repository, so GitHub to noise ChatTTS. And as you can see on the right side here, this is using the AGPL version 3 license. You can click on it and you'll find the license text and description. And let's go back again, because here's a little difference. We have on the one side the code base of ChatTTS, which is that AGPL 3 license. And on the other side we have the model, and the model is having, or is using, having, has a different license. So if you scroll a little bit down on the README page, we have this field of license. So you can see the code here is published under that AGPL 3 license, but the model is licensed under this specific license, which is meant for educational and research use and cannot be used for commercial or illegal, I hope this is obvious, purposes. They added some small amount of high frequency noise into the data before training the actual model. So it is not too easy, hopefully, to use the model for purposes that it is not meant to be for. And while being on the GitHub page, let's take a small look to the used code for developing ChatTTS. And you can see this on the upper right corner here, that it is mainly or exclusively developed in Python programming language. And again, we can see some stars. So this is pretty famous, nearly 30,000 stars on that GitHub repository. And by the last changes or commits, you can see 3 weeks ago. So this seems to be a pretty active development of ChatTTS. When it comes to the supported languages by ChatTTS, this is by now limited to 2 languages, as you can see on the GitHub page. So on the one side to English and Chinese. Does ChatTTS offer the capability to clone your own voice or fine-tune the existing model on your personal voice? As far as I see the README, no. But please correct me in the comments if I'm wrong. So ChatTTS has been trained on Chinese and English audio data, as you can see here, but in my opinion it does not support fine-tuning or voice cloning from scratch. How can you run ChatTTS locally on your personal computer? And according to the README, there are 2 ways. One is cloning the repository, so use the source code version and build ChatTTS locally yourself. I guess preferred in in the Python virtual environment, but I will give this a closer look in the in detail video. Or you can use the pre-built package, so this pip install ChatTTS. And as ChatTTS is Python based, so it's not really surprising that it is installed by running pip, so the package installer install ChatTTS package. And the README also shows some basic usage, so how you can integrate it into your Python applications, or you can use Python to synthesize your individual audio here. Which operating systems are supported by ChatTTS? And again, GitHub page my friend. So I did not find any specific information about Linux, Windows, macOS. But as it's a Python-based repository, I guess all operating systems that are able to run up-to-date Python versions should be fine. So if I take a look to the requirements txt, for example, you can see some dependencies. So typical Python dependencies. If you are able to satisfy these dependencies, you should be good to go. What is special about ChatTTS? In my personal opinion, I like the idea to add tags. It's not really like SSML, so speech synthesis markup language, which is way more flexible, but you can add this text by now laughter and breaks to make it more individual output. So as written in the README, in this example, we can add this tags for breaks or for laughter. Besides laughter, can we add anything else or control anything else? And by now, no, just laugh and breaks are supported. But I'll keep an eye on ChatTTS. And again, please let me know in the comments on what you think on ChatTTS and what you would like to see in my ChatTTS more in detail look and tutorial step-by-step video. When it comes to the homepage of MAS 5 text-to-speech, we have this camp.ai website here offering some capable speech and translation AI as it's written here on the homepage, but I'm honestly more interested in the GitHub page of that. So let's hop on to their GitHub page. I'll put all the links in the description box below. And as you can see, default GitHub page. And now let's take a closer look, chapter by chapter, onto the GitHub page. Let's start taking a look to the license. This is, according to the GitHub repository, HGPL in version 3 license. And let's scroll down the README to the chapter license here. So we are open sourcing MAS 5 in English. So the model is just released or trained or public, whatever, for English language under this license. If you have commercial interests, you should contact camp.ai by mail. Let's see the programming language of MAS 5, so the code that is open sourced under that GitHub repository. And that's a quick one because it's mostly based on Jupyter notebooks, so you can run it locally using Jupyter Notebook, Python environment, whatever, or you can use Google Drive or Google Cloud based Jupyter Notebook instance. We'll come to that later on in the ways you can run MAS 5. Which languages are supported by MAS 5? And this is really a quick win. It is English only. Can MAS 5 be used to clone or fine-tune your personal artificial text-to-speech voice? In general, I think yes, because according to the README on the GitHub repository, if you take a look here, you can input an audio reference file between 2 and 12 seconds with the hint that 6 seconds should provide optimal results. And this reference audio should be enough. It is like that zero shot thing. And you can choose between a deep clone, as it's mentioned here, which is taking a more compute resource than a non-deep clone. And I will give both of these a closer look in my upcoming in detail MAS 5 technical walkthrough video. I've recorded just for the quick test 2 6 or 7 seconds reference phrases and put these phrases into this demo Google Colab notebook mentioned here. I can show it to you here. So this is the notebook I've adjusted with my personal example and a textual transcript, which is required for this deep clone, as it's mentioned here. And let's just listen to my input audio, which I've recorded a little bit more emotional to see how the model deals with this up and downs in the pitch. Hello, Thorsten-Voice here. I am excited what MAS 5 makes out of a few seconds audio. And I have started this task with a deep clone to speak this reference phrase output. And on this Google Jupyter Notebook instance, which is the free version, this task is running for 2 hours now, and I'm not too sure if this is a mistake by myself, or if this instance is taking really so long, how can you run Mars 5 on your local computer? So according to the README in GitHub, obviously you can use their website, and it exists not just in English, but in more than 140 languages. But we should focus on what's running locally and privacy aware on your own computer. And you can use the Colab notebook, which is looking like this if you run it on the Google Cloud, or you can run Jupyter notebooks locally in a Python virtual environment. And I will give this a look in a separate video. But you can also use an online demo here, which looks like this. So there are plenty of ways you can take a first look, or you can run it locally. So let's go back to the quick start here. So if you choose to run it locally, it's Python based, so you can run it using the Python package management with some sort of requirements as are listed here. And the README shows all the required steps to load the model and to synthesize audio and to choose whether this deep clone or not, or how you can put the transcript text to support that deep clone. So the documentation is pretty good on that aspect, and how you perform the synthesis using Python code. Or alternatively, you can run a Docker instance, as it's written here, to use Docker. The Docker file is included in the repository. So if you scroll to the upper side, you have on the one side the requirements.txt file listing all the Python dependencies if you choose to build it yourself locally using Python, or inside this Docker folder you have the Docker file describing how the image is being generated for the Docker instance, for the container image. So run it locally using a Jupyter notebook, run it locally Python native, or run it locally on your Docker setup. On which operating systems is Mars 5 working? So the README is not telling anything about supported operating systems, but as it's Python and Jupyter notebook based, I guess that all operating systems that are able to satisfy the called Python dependencies will work with Mars 5. How does Mars 5 sound when you put in a 6-second audio reference file by myself with a little bit more emotional input, so ups and downs? To find this out, I originally tried this Jupyter notebook I can share with you now. But this step to clone my voice and to do the reference phrase listed here, this process is running for hours now, and I have no idea if this is normal or if I made any mistake. But luckily, the project, they offer an online demo here, so you can just see this online demo. And if you hit that link, this will bring you to this website where you can use, I guess, a Hugging Face space that is integrated here, and you can enter the phrase you would like to be spoken by the model, and you can add a reference phrase with that 6 or 7 seconds of audio. And I've put in a more emotional speech to see how the model can deal with the ups and downs in the voice. So let's listen to my reference original recording. Hello, Thorsten-Voice here. I am excited what Mars 5 makes out of a few seconds audio. Hello. Okay, so that's the input. And to do this sort of deep cloning, I guess that's the way they call it, you have to transcribe the text spoken in the reference phrase. So I've done this here in the transcript of voice reference, and I kept all the other parameters by default or in the default values. And if you hit generate, the model or this space or website will generate a few versions of output. So I would say let's listen to these so you get an idea. So let's put on this.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am curious on the
result. Okay, no idea what happened to the result, but okay, please let me know in the comments on what you think after hearing my the reference phrase here.
Oh, Thorsten-Voice here. I am excited.
And now let's listen to the second generated example.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am curious.
Okay, obviously the model seems not to like my result, but in my personal opinion, this does not sound like me. But the pitch or the ups and downs might be adopted by the model. So let's hear another one.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models.
Let's take, for example, the last one.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models.
Sounds a little bit like compare several available models. So I've not recorded this in a drunk way. So okay. MetaVoice text-to-speech is, according to their README on their GitHub repository, is an English-based text-to-speech solution with that zero-shot voice cloning. So just upload a 30-second reference audio to clone your voice and use your voice clone as text-to-speech voice. So let's find out how this sounds if I take a 30 seconds audio of myself. And to test this easily out, I will use this Hugging Face space provided with a link on their README. So let's go to the Hugging Face space, and this works pretty simple. You have to enter obviously your text that should be spoken. So in this case, my reference test phrase, good morning, this phrase is the reference, and so on. I will stick with the default parameters, and you can choose between a preset voice and to upload your reference audio, which I have done in this case. So I've taken a 30-second audio clip sounding like this. For testing purposes, to test the MetaVoice functionality of zero-shot voice cloning with a clear English. Okay, so you definitely hear my German accent, but this should not be the point. And now let's listen how the model synthesized this text here based on my reference audio input.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am curious on the result.
Okay, obviously I cannot be objective as it's my voice, but please let me know what do you think on the clone voice quality based on 30-second input. Let's give MetaVoice TTS homepage or homepages a first view. So starting with the GitHub URL here. So GitHub MetaVoice.io, MetaVoice source repository. And on the upper right you can see their linked homepage. That is the MetaVoice domain. So, now let's go directly to their homepage. So let's hit this, the MetaVoice domain. Pretty clean website with just one click to request access. So that's all you can click here. So let's go back to the GitHub page and let's check out this one. Let's start by taking a look to the license, and this is Apache 2 license as pointed out here. So if you scroll a little bit down to the intro, we can see that they are releasing MetaVoice under the Apache 2 license. It can be used without restrictions. let's take a look to the programming language of MetaVoice TTS. And as you can see on their GitHub page, it is mainly exclusively based or developed in Python code, and they add some Jupyter Notebook and Dockerfile. We'll come to that in a moment when we take a look on how you can run MetaVoice TTS. A short view on their code, you can see this requirements txt file, which is, as you probably already know, important for installing it the Python way by source. They include these files for the Jupyter Notebook, for the Colab or Jupyter Notebook code, and we have the Docker file if you build your Docker container instance, but again, we'll come to this in a moment. What languages are supported by MetaVoice TTS? Obviously, English is supported, and according to their README, sorry, German bug. They say you should be able to do zero-shot voice cloning for other languages with 1 minute of training, so reference audio input data, but I did not try this out myself, but I will try this. I will try this in my upcoming video where I will give MetaVoice TTS a closer, more in detail, step-by-step look. So that's what I would like to say. How can you run MetaVoice text-to-speech? So if you would like to just play around with it, feel free to use their Hugging Face space or a Jupyter Notebook in, for example, Google Colab. But if you would like to run it locally, you can, on the one side, run it as Docker container. So there are 2 containers, one for the server process here and one for the web-based user interface. Let's take a short look to their Docker Compose file here in the repository. And here you can see, if you scroll a little bit down, there are 2 services that will be hosted. One is the server process or the server container image, and one is the user interface. So you can easily run it by Docker as container instances, and I will give obviously this a closer look when I make my special video on MetaVoice text-to-speech. And if you do not like to run it as Docker instance, you can obviously run it the Python way, installing some dependencies at first, and then you have the Python way, so you can run the pip installer, satisfy requirements, and build the Python code by source. Which operating systems are supported by MetaVoice? So the README documentation does not specify any operating systems supported or not supported, but as it's mainly Python based, I guess, please correct me if I'm wrong on that, I guess if you can satisfy your Python or your system dependencies as mentioned here, so FFmpeg obviously, Poetry or the Python package management, if you can satisfy these and the dependencies listed in our requirements txt file, I guess you should be able to run MetaVoice TTS. Now let's take a look to Parler. Parler is a TTS model provided by Hugging Face. And talking about Hugging Face, first of all, if you watch this video from the beginning to now, thanks. I know it is a long video, but honestly, it is the fault of Weeby. He pointed out so many great text-to-speech projects. So just kidding, Weeby. Thanks for pointing to these cool projects. But we used Hugging Face spaces till now to play around with the TTS models easily without any local installation. But now Parler is natively provided by Hugging Face. So let's first of all again start with an audio sample and then take a look to the GitHub and information on their README. I guess it is needless to say that a text-to-speech model provided natively by Hugging Face has a space on Hugging Face to easily play around with that Parler TTS model. So if you would like to play around with it, just hop on to their space of Parler, link in the description obviously, and in comparison to other models we've played around with and we have seen so far, Parler has a prompt input, so you can add a description of how your voice or how the voice should sound like, and they provide some additional information and tips, so you might add very clear audio to your prompt to generate highest quality, and can use punctuations and so on. So they provide some additional tips for prompting. I stick at first with the default, just modified the input text to the phrase we used already to test the other models. And if you just hit generate audio, this is the result.
Good morning. This phrase is the reference to compare several available and free TTS or TS models. I'm curious on the result.
I like this one. And this is not just because Weebee posted this on LinkedIn and this is their model, but please let me know what you think. But out of the box, I really like this. Yeah. So now let's play around with another description. So in a very poor recording quality, a female speaker, but we stick with the same input text and hit generate audio. And let's listen to the output.
Good morning. This phrase is a reference to compare several available and free TS or TS models. I am curious on the result.
Yeah, I really like this one so far. Which license is Parler using? So, and again, let's take a look to the GitHub page, and you can see that Parler is under Apache 2.0 license. And if you scroll a little bit down in the intro text, you can see that Parler TTS is fully open source release, datasets preprocessing, and so on, enabling the community building their own cool, powerful TTS models. As said multiple times, I will do an in-detail video on each of these projects, obviously including Parler, to give this project a closer look. When it comes to the programming language of Parler TTS by Hugging Face, this is pretty straightforward because it is Python. That's all. 100% pure Python code, according to GitHub. Can Parler be used to clone or fine-tune your personal artificial text-to-speech or TTS voice? From what we have seen so far, you can add a prompt, or you can design a voice output or interpretation of a voice by prompting. But can I use Parler TTS to create my personal voice clone? And from what I have seen so far, I would say yes. And again, please correct me if I'm wrong in the comments, because if we take a look to the README, I really like the READMEs on GitHub. All of these projects, they provide really cool documentation, so shout out to all of the projects. You do an amazing job, not just in the coding aspect and training aspect, but also the documentation and the structure of your README files is really great and nice and good to read. So where have I been? Yeah. If you take a look to this important part here, Hugging Face has or had released 2 new checkpoints on August the 8th, 2024, which is pretty up to date because today it is August the 10th, 2024. So you can use these checkpoints, and let's go down. There is a headline or a header called training. So you can obviously do a training process based on your own data. I have not done this, but I will give this a closer look in the special Parler only tutorial video. But let's hop on to this training folder, And as you can see here is a training documentation, a really long document. You have to create or find your voice data set. Obviously, if you would like to clone your own voice data, you need the speech data and a textual transcription of the spoken audio data, obviously. So the question is, does Parler support voice cloning or fine-tune the existing model checkpoints for your personal artificial text-to-speech voice? Yes. How can you run Parler TTS locally on your private computer? So as Parler is 100% Python-based, according to the GitHub statistics, you can use the Python package management pip installer way. I know, shocking, isn't it? So you can run pip install with the repository name and can use Python code to use Parler. So this will be obviously be part of my in detail look tutorial video on Parler. Again, let me know in the comments if you have any specific questions on one of these projects which I should keep in mind while doing my tutorials on that specific project. As Parler TTS is based on pure Python code, you should be able to run it on every operating system, regardless if it's Windows or Mac OS or Linux, that supports running up-to-date Python versions. By the way, I put lots of passion, effort and time into this video. So if you like this video, give it a thumbs up, let me know in the comments on what you think. And if you like my content in general, please subscribe to my channel and share my channel with other voice technology enthusiasts. So thanks a lot for your support. Last but not least, let's take a look to Toucan TTS, which is provided by the University of Stuttgart, so German university. So let's take a look and start with an audio sample. And this project, so Toucan TTS, provides lots of interactive demos on Hugging Face spaces. So let's start with the last entry here. You can design the voice of a speaker who does not exist. So let's hit this link, bringing us to Hugging Face. Let's take our default text input, so the reference phrase we have seen and heard in the previous tests too, and I've chosen the English text and English accent, and I've let all the other parameters in their default value. Just hit submit and let's hear the result.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am curious on the result.
Sounding a little bit noisy in the background, but I really like the speech flow, so really nice result. Now let's go back to the homepage or to the README on their GitHub page and see what we got there. Let's take a look to license and programming language. So starting with the license, you can see that the Toucan TTS project is licensed under Apache 2.0 license. And a little bit more down on that page, you can see that the code base is, according to these GitHub statistics, 100% pure Python based. Can I use Toucan TTS to do this zero-shot 30 seconds input reference voice cloning and or a full voice clone based on my personal voice dataset? And from what I've seen so far, I would say yes and yes. So let's start with the first one. Can Toucan TTS do this zero-shot magic with just minimum input data? So let's go to the README and to this field with the interactive demos. And if you hit the first link, this will bring you to this Hugging Face space again. and I will use our default and lovely text. Good morning, this phrase, and so on. I've set the language of this text here to English because it is an English text. And I've uploaded my 30-second audio reference data from the MetaVoice testing. So let's just hear it, or a part of it. MetaVoice functionality of zero-shot voice cloning with a clear English-based. So, and I've taken this 30-second reference phrase, kept all the default values, hit submit, and this is the result.
Good morning. This phrase is the reference to compare several available and free TTS or TTS models. I am curious on the result.
I think, in my opinion, even if I cannot be objective, obviously, I think this is not really a pure clone. Maybe it's the speech flow learned from the input text, but please let me know on what you think compared to the reference input text. This audio input is meant for testing purposes, and this is the result.
Good morning. This phrase is the reference to compare several of.
And as you can see by the title, Toucan TTS in 7,000 languages, which seems really a lot. So let's see how many languages exist. Okay, so there are 7,139 officially known languages in the world. So wow, this is impressive if Toucan TTS supports 7,000 of these languages. For the second aspect of voice cloning, let's go back to the GitHub page again and scroll down to the field creating a new training recipe or training pipeline. So according just to that headline, I guess you can create a new model based on a training configuration. So training your own model based on that recipe build is super easy. And maybe I will find out in a specific video tutorial on Toucan TTS. How and on which operating systems can Toucan TTS run, as it is pure Python implementation? This should not be too complicated in general. So according to documentation, they recommend Python in version 3.10, and obviously you have to satisfy some dependencies. But when take a look to this list, this does not look too complicated. And they recommend creating a Python virtual environment for running Toucan TTS. But this seems to be pretty straightforward if you have any experience with Python-based applications. So I guess this will run on Linux, Windows, and macOS if you have Python 3.10 running, which should not be a problem on these operating systems. Finally, we made it. If you watched the complete video, so thanks for your patience, thanks for your interest. And to sum it up, here is a short overview of all the projects and information that has been part of this video. And as I've mentioned multiple times already, I will give all of these time after time more in detail technical walkthrough, step-by-step tutorial video topic each. Let me say thank you to all of these cool projects, to all the great people help creating an open source voice technology text-to-speech TTS future. I really appreciate all of your great efforts. Talking about efforts, this video creation and research and try and error took really long amount of time. So please, if you would like to support my work, share this video and my channel with other voice technology enthusiasts. Give this video a thumb up. Let me know in the comments what you think on this video in general, on this new focus and zoom feature to enable a better readability. I guess I'm done for this video. Hope you like it, and if you like, we might see us next time. Bye!
It has been a pleasure watching. Thank you.